हेलो स्टूडेंट्स, ਅਸੀਂ ਆਲਰੇਡੀ ਆ ਤਿੰਨ ਚੀਜ਼ਾਂ ਡਿਰਾਈਵ ਕਰ ਚੁੱਕੇ ਹਾਂ ਅਪ ਟੂ ਲੈਕਚਰ ਨੰਬਰ 3rd drift velocity is equal to E over m multiplied tau, I is equal to n EAVD and I is equal to n E square AE over m multiplied tau. Now the next topic, so we will be talking about today Ohm's law. Ohm's law. I will also be introducing the term resistance and resistivity. Ohm's law, resistance and resistivity. These are the things that I will be talking about today, and we will also try to discuss the factors on which the resistance and resistivity depends. So before moving on to all these things, let us talk about Ohm's law first. Ohm's law, ये टॉपिक ਅਸੀਂ क्लास 10th में भी पढ़े हैं. Ohm's law, so it states that the current flowing through a conductor is directly proportional to the applied potential difference. Across its ends is directly proportional to the applied potential difference across the terminals. Across its terminals. But some condition is there provided temperature and other physical conditions are kept constant. So this is what is Ohm's law. Please make a note of this. In simple form, we will say that V proportional to capital V, the potential V is directly proportional to I, and if I replace this proportional sign with equal to, then I need a constant. So that constant is R. That constant is R. So V is equal to Ri. So from here I will get R is equal to V over. So this R is called as a resistance of the conductor of the R is equal to V over I. Now we have to define what is the resistance. So resistance is we already know that it is the obstruction offered to the flow of current through a conductor. So this is the obstruction offered by the conductor to the flow of current. तो कोई भी कंडक्टर नहीं चाहता कि करंट फ्लो कर जाए, so it will try to resist. So that is called as R. Now our topic is resistance. So it is defined as the property of substance. Substance, or we will say that the conductor which oppose the flow, which oppose the flow of current through it. And we have also seen that R is equal to the ratio of the applied potential difference to the current flowing through a conductor. R is equal to V over. It's SI unit. When V is equal to 1 volt and I is equal to 1 ampere, then R is equal to 1 volt over 1 ampere. So this is called as 1 ohm. So 1 volt per ampere. 1 volt per ampere. So now we have to define this. What is 1 ohm? So 1 ohm is the resistance between 2 points of a conductor. The resistance between the two ends of so 1 ohm is the resistance between the two ends of a conductor when a potential difference of 1 volt is applied to its applied to its ends and a current of 1 ampere flows through it. So that resistance is said to be 1 ohm, for which a current of 1 ampere flows through a conductor for applied potential difference of 1 volt. So शब्द इधर उधर हो सकते हैं, कोई प्रॉब्लम नहीं है. You can make a note of this also. So 1 ohm is equal to, but it's the symbol होता है omega. 1 omega is equal to 1 volt per. I hope that this is the note कर आएगा. Next is its dimensions. So dimensions of R. We already know that this is equal to V over I. V stands for work per unit charge. Work per unit charge multiply I. I stands for current. Now the dimensions of work are M L square e raised to power minus 2 over charge is 80 and current is I. So from here we get the dimensions M L square e raised to power minus 3 a raised to power minus. So these are the dimensions of resistance. So please make a note of this also. Next is resistivity. Resistivity. So the resistance is the property of the material. Resistance is the property of the material as well as the dimensions of the conductor. So the resistance of a conductor is directly proportional to the length of the conductor. Is directly proportional to the length of. We will prove these things later on today also. The resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to the area of the cross section. If I combine these two things, what I will get is R is directly proportional to L over T. So means the resistance depends on the dimensions of the conductor through which the current is flowing. So R is directly proportional to length to area and inversely proportional to area. Now if I want to remove this constant, then I will have to use a constant. So R is equal to rho L over T. So this constant that I have used here is called as resistivity. But this resistivity of conductor is also called as specific resistance. So this is the property only of the material. So it is material property. ये केवल और केवल मटेरियल से डिपेंड करती है. It does not depend on the dimensions of the conductor. So from here I will get rho is equal to R multiply A over L. Now it's SI unit. So since resistance is measured as ohm, area meter square, length meter, so its unit is ohm meter or written as mega meter. So ohm meter is its unit. So please make a note of this also. Now its dimensions. So dimensions of rho will be equal to dimensions of R, A and L. So dimensions of R are M, L square, e raised to power minus 3, a raised to power minus 2. Area stands for L square, length stands for L. So this will get cancelled with this power 1. So M L raised to power 3, e raised to power minus 3, a raised to power minus. So these are the dimensions of resistance. So please make a note of this. Now I will talk about the Ohm's law again. The proof of Ohm's law. So we know that I is equal to, we have I is equal to n e square a e over m multiply tau. This is what we have already derived in our previous lectures. So V is equal to, V is equal to, or E is equal to dV over dr. So E is equal to V over L. E is equal to V over L. So I will use this at the place of this. So therefore, I is equal to now n e square a over m, and at the place of E I am using V over L. So multiply V over L multiply tau. So now have a look at this expression. So if I rearrange all these things, what I will get is I is equal to n e square over m. Tau I am using here a over L multiply V. So if I cross multiply these things, what I will get is V over I. V over I. V over I is equal to m over n e square tau. So this will get here multiply L over A. And this is similar to the formula that we have already used. R is equal to rho L over A. So here this term stands for rho. So that is equal to rho L over A. So therefore V over I. Therefore V over I is equal to. So this is how we prove resistance. Ohm's law is proved since the ratio of V over I is R, or on cross multiplication we will get that V is equal to IR. So that was the Ohm's law. So this is the proof of the Ohm's law. Now from here we have got one or two other things now. So we have got resistivity is equal to m over n e square tau. So look at these terms now. Mass of the charge E, tau is the relaxation time, and n is the charge density or number of charges per unit volume. So that's why only we said that this resistivity is a property of the medium. It is property of material only. Because all these things are constant for a particular medium or material. So this is a property of the medium. It does not depend on the dimensions, whereas the resistance depends on the dimensions. And R, we have seen that R is equal to m over n e square tau multiply L over A. So this resistance depends on the material as well as on the dimensions of the conductor. With all these things, we will close for today. Thank you. Have a nice day.